Additionally, what we can do to make our plots contain a little bit more data is add more points to the same plot. Sometimes you want to be able to plot additional data on top of this same visualization if the data are related to each other. So for example, we could also plot the frequency of burins, which is another tool type, as a function of core and flake scrapers. Perhaps that's something we're interested in for our analysis. And the way that we would do that is to keep this plot that we've already created using the code here on line 27 of our script, but to then add a second function. This function is called the points function. And you can pull up the help page for this if you would like, and you'll see that it's pretty much similar to the plot function. However, instead of producing a plot and laying points onto that plot, it is simply used to add points to a pre-existing plot. So here I would type BU, which is the column name for burins that you can see if you were to pull up the call names for ESA sites. CFS, which is core and flake scrapers. Do, again, data equals ESA sites as before. And let's add in PCH equals, let's try 3. And COL equals, let's do 0000FF50. Now, plotting as I just did here, what I did was say, okay, on top of the plot that we've already created with the red circles that are transparent, add new points. These points will be burin counts as a function of core and flake scraper counts from the ESA sites data frame. The point style is 3, which produces these plus signs, these crosses here, and the color is transparent blue, 50% transparent blue. 0000FF is blue, that's the hex code for blue, and adding a 50 to the end of that makes it 50% transparent. So you can see, again, there's a lot of overlapping data down here in the bottom left corner of the plot, where those blue crosses are a little bit darker than they are up in the top right. So now we're plotting two different sets of data on top of each other, and this plot is a little bit more complicated and perhaps a little bit more difficult to read, because now, as you can see, our y-axis still just says microliths, even though we're actually plotting burins and microliths on the y-axis. So we will need to change the label there. We can perhaps change it to count. And if I run that again, now I've changed the y-axis label. It's a little bit more general. But which color and point style is for microliths and which one is for burins? In order to portray this, we can add a legend to our plot, a key that will make this clear. We can do this using a couple different approaches, but the simplest one is to use the legend function. Now, if you type in legend and you pull up the help page for it, there's a lot of different arguments, again, that this function will take. The basic ones are that it requires x and y coordinates. This is where the legend will be placed on your plot. So let's place it at a value of -1 on the x-axis and a value of, it looks like maybe 14 on the y-axis. So that's where our legend is going to be placed. We want then the contents of the legend. So using the legend argument within the legend function, we can say that this is a legend of microliths and of burins. And because those are just words, they have to go in quotes. And I'm concatenating them. I'm putting them within that C function so that they're treated as a combined kind of set of values for that legend argument. So it understands that there's two values there. Let's, just because I don't really like the look of the pluses, let's change that to a 16 as well and redo the plot. Yeah, I think this looks a little bit better. We've got open circles, transparent blue, and transparent red. So in the legend, now that we've got this, let's specify that we are plotting PCH 16 points, and our colors are also going to be concatenated. We're going to concatenate the hex code for red, which is Burins, or which was microliths, sorry, and a hex code then for blue, which was for the Burins that we added. So if I run that, now we've got a legend that has appeared on our plot. It's a little bit big compared to the other aspects of the plot. We can control that using another argument called the CEX argument. If we set CEX to 0.75, it will shrink that legend a little bit. The default CEX argument, which controls the size of different things, is 1. So if you make it smaller than 1, you're making the object smaller. If you make it larger than 1, it's getting bigger. Notice that whenever I ran that legend function again, it simply added another legend, this time a smaller one, on top of the one that we already added. This is a common thing when you're layering elements on top of a plot. You'll need to go back, run the base plot again, add the points back, and now add the legend that's a little bit smaller and a little bit nicer looking. So this is getting to be a pretty nice looking plot, I think. We've got this nice legend there up in the top left. And the way we're controlling it, as I said, is through these x and y coordinates, but there is actually also another way to do this, where if you just type, instead of x and y, if I put top left right there, it will add a legend that is flush into the top left corner of the plot. Again, you'll need to run everything again so that it looks nice. But this is also a pretty simple way, so you don't need to mess around with finding the coordinates of where you want to place the legend. You can just say top left, top right, bottom left, whatever. And you would see that this is an option if you were to open the help page for the legend function. And so that, I think, produces a pretty nice looking plot for the time being. And of course, there are still a lot of other things that you can add to it. You can manipulate these plots as you see fit. Again, check the help pages for the plot function, for the points function, for the legend function, and you'll see all the different options that you have for creating scatter plots in this way.